In order to find all the roots of the polynomial without giving a root, we first want to do the rational root theorem, list all the possibilities for roots. P over Q, P being all the factors of the constant term, the factors of 3 are 1 and 3. Q being all the factors of the leading coefficient, which is also 3. And then any combination of those. So 1 over 1 could be positive or negative is 1. 3 divided by 1 is 3. 1 divided by 3 is 1/3. And 3 divided by 1, or 3 divided by 3 is 1. We already have that. We would test these numbers and see which one works, which one gives me a remainder of 0, or which one I plug in. I can plug in the numbers for x and see which one gives me 0. I'm going to try synthetic division. We're going to start with 1 and see which one gives me 0. 3, -5, -11, -3. The 3 comes straight down. 1 times 3 is 3. -5 plus 3 is -2. 1 times -2 is -2. We add those together, we get -13. 1 times -13 is -13. We add those together, we get -16. That did not work, so 1 is not a root. Let's try -1. 3, -5, -11, and -3. The 3 comes straight down. -1 times 3 is -3. We add those together, we get -8. -1 times -8 is +8. We add those together, we get -3. -1 times -3 is +3. We get 0. So what do we know about -1? We know -1 is a root. And if -1 is a root, we know x plus 1 is a factor. So we can rewrite f of x as x plus 1 times the quotient we got here, which would be 3x squared minus 8x minus 3. At this point, we want to solve this quadratic, 3x squared minus 8x minus 3. Let's see if we can factor that. We learned how to factor using the box method. 3x squared, -3. We multiply those two together. What times what will give me -9x squared. And the same two numbers have to add to give me the middle number, -8x. Looks like those two numbers are -9x and +1x. We can put those inside our box. 3x squared and -9x can be divided by 3x. 1x and -3 can be divided by 1. 3x squared and 1x can be divided by x. -9x and -3 can be divided by -3. So what do we end up with? We end up with f of x is equal to x plus 1 times 3x minus plus 1 times x minus 3. We already know -1 is a root, so we would set these other two equal to 0 to find the other two roots. 3x plus 1 equals 0, subtract 1 from both sides. So 3x equals -1 and divide by 3. So x equals -1/3 is also a root. X minus 3 equals 0. We would add 3 to both sides, and we get x equals 3. So we have 3 roots, 3, -1/3, and x equals -1 would be our 3 roots. Let's try another cubic function. We got to list all the possibilities, the possible rational functions, p over q. P is all the factors of the constant term, -4, which would be 1, 2, and 4. Q is all the factors of the leading coefficient, which is 1, which is just 1. So our possibilities are 1, 2 divided by 1 is 2, and 4 divided by 1 is 4. We're going to try those until we find one that works. 1, 13, 20, and -4. The 1 comes down. 1 times 1 is 1. 13 plus 1 is 14. 1 times 14 is 14. We add those together, we get 34. 34 times 1 is 34, plus -4 is 30. So that one did not work. So 1 is not a root. Let's try -1. 1, 13, 20, and -4. -1 is -1. 13 times -1 is 12. -1 times 12 is -12. 20 plus -12 is 8. -1 times 8 is -8. We add those together, we get -12. We also know -1 is not a root. So let's try 2. 1, 13, 20, and -4. 2 times 1 is 2. 13 plus 2 is 15. 2 times 15 is 30. 20 plus 30 is 50. 2 times 50 is a 100, and that's 96. Clearly not 2 or 0. Let's try negative 2. We just keep trying until we find one that works. We could use other methods like graphing to help us narrow down our list. But since we're not using graphing calculators, we're going to see if we can figure it out. 13 and negative 2 is 11. Negative 2 times 11 is negative 22. Plus 20 is negative 2. Negative 2 times negative 2 is positive 4. Negative 4 plus 4 is 4. Finally, we found a root. So f of x would be equal to x plus 2 times x squared, coming from the quotient, plus 11x minus 2. So what do we know? We know x equals negative 2 is one of our roots. Let's see if we can use the quadratic formula here. It clearly can't. Let's see if we can use the quadratic formula on x squared plus 11x minus 2, because there's no way that can be factored, because nothing multiplies to give me negative 2 that adds to give me an 11. So x equals negative 11 plus or minus the square root of 11 squared minus 4 times a is 1 times c is negative 2 all over 2 times a, which is 1. So we get negative 11 plus or minus the square root. 121 plus 8 is 129 all over 2. I'm pretty sure that can't be simplified. So our other two roots are negative 11 plus or minus the square root of 129 all over 2. We're going to find all the roots of a 4th degree polynomial. In order to do that, we need to list all the possible rational roots, p over q, p being all the factors of 8. The factors of 8 are 1, 2, 4, and 8. Q being all the factors of the leading coefficient. The leading coefficient here is 1, so all the factors of 1 is just 1. We list all those possibilities. 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4, and 8 divided by 1 is 8. We would do synthetic substitution or synthetic division to figure out if one of those possible roots is actually a root. Let's start with x equals 1. The 1 comes straight down. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. 6 plus negative 2 is 4. 1 times 4 is 4. Negative 12 plus 4 is negative 8. 1 times negative 8 is negative 8. And 8 plus negative 8 is 0. We got lucky that x equals 1 is a root, and it was the first one we tried. So what can we do? We can write f of x as x minus 1, the factor, times x to the third minus 2x squared plus 4x minus 8. P over Q is going to be the same because the constant term is still 8, the leading coefficient is still 1, so this is still my list of possibilities. It's possible that the same number could work twice. It's possible that it doesn't work twice. So let's try 1 again with the cubic polynomial here. We have 1, negative 2, 4, and negative 8. The 1 comes straight down. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. We add those together, we get 3. 1 times 3 is 3, and we get negative 5. So clearly, 1 is not a root again. Let's try negative 1. And I would probably do all this work off to the side until I find one that works. Negative 1 times 1 is negative 1. We add those together, we get negative 3. Negative 1 times negative 3 is positive 3. We add those together, we get 7. Negative 1 times 7 is negative 7. We add those together, we get negative 15. Clearly not 0. Let's try 2. X equals 2. 1, negative 2, 4, and negative 8. We're trying to get down to a quadratic. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. 4 plus 0 is 4. And 2 times 4 is 8. Negative 8 plus 8 is 0. So what do we also know? We know that x equals 2 is a root. And now we can rewrite f of x as x minus 1. We can break this x to the third piece down into x minus 2, that was the factor we found, times the quotient here, which is x squared plus 4. We solved the equation x squared plus 4 equals 0. We can solve that by taking square roots. Subtract 4 from both sides. X squared equals -4. We take the square root of both sides. The square and the square root cancel out. And x equals plus or minus the square root of -4. The square root of a negative number is I, and the square root of 4 is 2. So this is plus or minus 2i. So our 4 roots would be x equals 1, x equals 2, and x equals plus or minus 2i.